In this video, we're going to learn about the fundamental counting principle and probability. Use the fundamental counting principle to calculate the following probabilities. Write your answers as percents rounded to 2 decimal places. So we're told a multiple choice quiz has 7 questions and 4 possible answers per question. And we're asked how many different ways are there to answer the 7 questions. So notice this isn't a probability problem yet. This is just asking us to find the number of ways that we can answer a multiple choice quiz with these requirements. So notice I have something set up here. Q1 is corresponding to question 1. Notice there's 7 questions, so I have these labeled Q1 through Q7. Okay. And these are what we call the choices we need to make, or another word I'm going to use is decisions. Okay. So for each choice or decision, we have some number of options. So here are the choices how to answer the question, and here we have 4 possible answers per question. So here we have options per choice. And I want you to think about these as you work with the fundamental counting principle, because we frequently, options and choices, we use them interchangeably or synonymously. You might say, how many options do I have? How many choices do I have? But we have a different meaning here. A choice is a decision, and there are 7 decisions you need to make how to answer each question, and your options are the 4 possible answers per question. And to help you find the options compared to the choices, look for the per question. So that's referring to the choices. Okay, so now by the fundamental counting principle, we can multiply the number of options per choice times each other. And in each case, there are 4 possible answers, so we have 4 options per question. Okay. So we'd multiply 4 times itself 7 times. And we have another way to write this in mathematical notation that's less tedious, and it's 4 to the 7th power. So remember, this means 7 factors of 4, which means multiplying 4 by itself 7 times. We're not multiplying 4 times 7, that's 28, okay? So let's just see what this number is. And that's 16,384. So in a multiple choice quiz with just 7 questions, there's 16,384 ways to answer it if you have 4 options per question. So now let's look at some probabilities, and these ones are going to relate back to this sample space. So we have a student who didn't study randomly guessed on each question. What is the probability the student got all of the answers correct? So maybe at some point in your life you wish this happened. So let's see how incredibly unlikely it is. Okay. Well, the sample space is a number of ways. I'm just going to put 4 to the 7th here. So lots of times we don't compute these to the end. The number of ways to answer the quiz, which we found is 4 to the 7th. Now, how would we get all of the answers correct? So now let's write these out a little bit again. So I've gotten the spots ready. Okay, so if our event space is getting all of the answers correct, well, how many ways are there to get a single answer correct? Well, 1 of the 4 possible answers is the correct answer. So for each one, there is 1 option that will give you the correct answer. So all of these are 1, and if we multiply them, that gives us a numerator of 1 to the 7th, which is just 1. Okay, so notice that makes sense. There's 1 way you can answer all the questions to get them all correct, okay, if there are multiple choice questions. So that means 1 out of your chances of getting it correct if you randomly guessed are 1 out of 16,384. Let's compute that and write that as a percent. And we'll see it's a very small number. So 1 divided by 16,384. And now we'll multiply this by 100. Okay. And we were told to round this to 2 decimal places. I'm going to round to 4. 2 decimal places would be 0.01. But let's go 0.0061. And remember, I multiplied by 100. Let's write that here. And sometimes when we see that, we think it needs to be changed from a decimal to a percent, but this is actually a percent. So 0.0061%. Okay, so that's the probability if you randomly guess of getting 100% on the quiz. Let's look at the next one. So again, we have the same scenario, 7 questions and 4 possible answers per question, and we're asked a student who didn't study randomly guessed on each question. What is the probability the student got all of the answers wrong? Okay. So we know the denominator is still going to be 4 to the 7th, so I'm just going to write this over here. So now we need to count the number of ways in the event space, which is getting all of the answers wrong. So looking at each question, remember there was one way to get an answer right. If there's 4 possible answers, there's 3 answers for each question that are wrong. So all of these numbers will be 3s. Okay, and notice this is 7 factors of 3, which we can write as 3 to the 7th. And we're going to multiply that by 100 to write it as a percent. So let's see what this equals. Okay, so I'm going to use 3 raised to the 7th divided by 4 raised to the 7th. And that gives us this. And now we need to change it to a percent. And we'll do 4 decimal places again. So 13.3484. 13.3484%. So this is good and bad news. So there's about a 13% chance if you randomly guess you won't get any of the questions right. Okay, but remember you're very unlikely to get them all right. And now for our last question. What is the probability the student answered questions 2 and 3 correct, or correctly, but the rest of them wrong? So, looking at our setup, questions 2 and 3, if you're going to answer them correct, you have one way to do that. And all the other ones are wrong, so there's 3 ways to get each of those wrong. Now we still have a denominator of 4 to the 7th. The top, this may seem a little bit silly, but it's 1 squared, 2 factors of 1, which is just 1, and then we have 5 factors of 3. And I'm just writing it this way. Sometimes it's useful to look at this. If you add up these exponents, you could see you made the right number of choices. You included everything. So 3 to the 5th over 4 to the 7th, and then we'll write that as a percent. Divided by 4 raised to the 7th. Gives us this times 100. So 1.4832%. Let's write that in red so we can see it. 1.4832%. Okay, so notice this isn't getting any 2 questions correct. This is specifically getting questions 2 and 3 correct.